Okay, rational exponents. We've been given, this is another rule of exponents we didn't talk about in our exponent laws. This exponent says if we have a base to the power of some fraction, it can be rewritten. Okay? The way it can be written is the denominator, or the bottom of the fraction, becomes the root, which we did talk about. Okay? And the top of the fraction becomes the new power. So we can write it where we deal with the root first, and then whatever that value is, take it to the power. Or we can apply the power first and then do the root after. I suggest to do whatever comes easiest to you. Okay? And in some situations, some might work better than others. So the first thing we're going to do is rearrange this and write it as a root and a power, instead of just an exponent with a fraction. So, underneath our root, what value goes in here?
5. Oh, 32.
That's right.
Oh, yeah.
What root is this?
5.
The fifth root. So the 5 goes here. Okay? And then the power on the outside becomes 4. We'll do the exact same thing, and we'll just solve it in a different order this time. So 32 to the power of 4 to the fifth root. Okay? So, anybody have a calculator on them? Try this out. What is the fifth root of 32? Anyone know?
No idea.
Okay, let's bring it on our calculator. Let's bring it up here. Oops. Oh, what is going on here? Sorry, this is freezing.
Nearly 6 points.
So when we do that on the calculator, the fifth root of 32. Okay, for here, I believe I have to hit the number 5, then the root of 32. No, that's wrong. It's wrong order. It's 32 to the fifth root is 2. Okay. So that value becomes 2 to the power of 4 in this case. And then what is 2 to the power of 4? That's right. Good. Let's do it in the other order. What's 32 to the power of 4? Okay, 1 million. What is it? 1 million? 48,000? 048. Okay, 48,000. 576. Beautiful. 1,048,576. What's the fifth root of that? 16. Okay, so one of the ways looked a little simpler in this version, and I usually suggest to do it this way to find the root of a number first, because it usually allows us to work with smaller bases. If we usually take it directly to the power first, we end up with a very large base where we have really no way of logically telling if our next step is a reasonable answer. Okay? So I usually suggest this method, but both of them work. As you guys can see, we came to the exact same answer. Okay? Now, the next thing I want us to go through is solving for a base when we have exponents. So let's say we have something like this. X to the power of 3 over 2 equals 27. Okay? What I want you guys to realize here is what we need to do is we need to get x by itself. Okay? So the x needs to get by itself in this question. I'm going to rewrite it in our root form so that we can get a better sense of what I need to do in order to get x by itself. So this x would be to what root? What would the root be? Would the 2 or the 3 go here? The 2. The 2 is the number on the bottom. And what exponent would it be to? 3. Good. So I've rewritten it this way so that it may be a little easier to see how to move things over. Now, we talked about this before. Because our exponent is on the outside, this is the first thing I want to move to the other side of the equation. What is the opposite operation of an exponent? A square root. But not a square root in this case. Because this is the power of 3, the opposite of this would be the third root. Okay? So we have to find the third root of 27 when we move this over. So this still stays as the square root of x is equal to the third root of 27. I'll write that in blue. So when we move the power of 3 over, it became the third root over here. Okay? Just like if we were adding, when we bring it to the other side, it would become subtraction. We use the opposite sign. Had we been multiplying, when we move it to the other side, it becomes division. A power, okay, so power of 3, when we move it to the other side, becomes a root. Okay? So the third root of 27, let's actually go about doing that to start off. What is the third root of 27? Good, so we simplify. But we still have square root of x. What would be the opposite of a squared root when I move it to the other side? So what power would I put it to? That's right. So if we had the square root, we know the opposite of that is to the power of 2. So when I move this over to the other side, this becomes x is equal to 3 to the power of 2. Okay. What is 3 to the power of 2? 9. Okay. So a complex question. We had to do a lot of moving things left and right around our equal sign. The entire page there. Okay, so this question here, we're looking for x again. I want to put this fractional exponent as a root and an exponent. So we know the denominator tells us the root, okay? So this will actually be the fifth root of x, all to the power of 2 in this case. Okay, so, to the power of 2. Thank you, Martina. Okay, so now that we've done this, because we're trying to solve for x, the goal is to isolate x. So I want to move my power of 2 first. When I move the power of 2 over first, what does it become? Square root. That's right. So it becomes a square root when I move it over. So we'll still have the fifth root of x over here, but this then becomes the square root of 16. Using your calculators, what is that? 4. Good. That's 4. So we simplified. We still have the fifth root of x. Now when I move the fifth root over, what does it become? It comes to the power of 5. That's the opposite operation. Good. So this becomes x is equal to 4 to the fifth, or 4 to the power of 5. Which, off the top of my head, I think is 1,024. Nah, I'm joking. I didn't get that off my head. I used the calculator. 1,024. Okay.